Hey guys, today we're going to move on to Unit 1, Lesson 3, and we're going to talk about equivalent ratios. We've kind of hit on this just a little bit in a few of the questions that we've had in the past, but today we're going to go into more detail about it. So, first question says, Mr. West uses the recipe to make a batch of soup. He often doubles or triples the recipe and freezes some of the soup. What ratio of cups of stock to the batches of soup should Mr. West use to make 1, 2, and 3 batches of soup? So we're going to use what we already know to solve the problem. So the first question says, how many cups of stock are needed to double the recipe? And then explain. So the first thing we need to do is think. When it says to double the recipe, we've talked about this when we were talking about our keywords. That keyword for double means that we're going to multiply, and when you double something, you're multiplying it by 2. So if we look up here, when we look at cups of stock, it said that you need 4 cups. So we would take 4 cups times 2, which would give us 8 cups of stock. Okay, so we would just explain that. We would say you multiply the cups needed by 2 to double. Okay, so B says how many cups of stock are needed to triple the recipe? Explain. So we do the same thing. So we know we need 4 cups for the original recipe. When we triple something, you multiply it by 3. So 4 times 3 would give you 12 cups of stock. And we explain the same thing again. You multiply by 3 to triple. C, write the ratio of cups of stock to batches of soup for 1, 2, and 3 batches of soup. So we know for 1 batch of soup, we need 4 cups of stock. So we put cups first to the batches of soup. So it would be 4 to 1. And then we know for 2 batches of soup, we need 8 cups. So the cups come first. It would be 8 to 2, and then 12 to 3. So D says, find the related rate and unit rate for each ratio. Remember, you divide the first quantity by the second quantity to find the related rate. What do you notice about all the rates and unit rates? So I'm going to write this over here to the side. So obviously our first one is 4 to 1. Okay? We don't need to divide, our bottom number is already 1. So then when we have 8 to 2, we divide by our bottom number, so divide both by 2, and we get 4 to 1 again. And then 12 to 3, divide by our bottom number, and you get 4 to 1. So the unit rate for all of these would be 4, because it's just the top number. So it says, what do you notice about all the rates and unit rates? Well, they are the same. They're all 4 to 1 and 4 for the unit rate. So, the ratio of cups of stock to batches of soup that you wrote and use what you know are equivalent ratios. So we want to make sure that we underline that or highlight that. Equivalent ratios. They all have the same related rate and unit rate. Each ratio of cups of stock to batches of soup has a unit rate of 4. The first quantity, which is the cups of stock in each ratio, is 4 times the second quantity, which is the batches of soup. You can make a table to show other equivalent ratios. So here you can see we have our cups of stock on the top, and we know that it's going up by 4 each time we go up. So you can see we have 4, 8, 12, 16, 20, 24, and 28. And on the bottom is our batches of soup, and it's going up by 1. So 1, 2, 3, 4, 5, 6, and 7. If you know a ratio, you can make a table with as many equivalent ratios as you want. In the problem on the previous page, the ratio was a rate, 4 cups of stock to 1 batch of soup. Many problems give a ratio that is not expressed as a rate. A caterer prepares fruit bowls for a luncheon. Each bowl has 8 grapes for every 3 strawberries. So we can see on this table that they didn't give us the rate. They gave us just a ratio, which is here. The ratio of grapes to strawberries in each bowl is 8:3. You can write other ratios equivalent to 8:3 by using multiplication. So you can see here that we're taking this 8 and we're multiplying it by 2 to get 16. So if we multiply that by 2, that means that we have to multiply this one by 2 to get 6. And then you can do the same thing with the next one. Start with your beginning ratio. They did 8 times 3 to get 24. So they would do 3 times 3 to get 9. And then they would do the same thing for the next one. 8 times 4 to get 32. And 3 times 4 to get 12. And this is where they are getting their equivalent ratios. So 8 times 5 is 40. And 3 times 5 is 15. So we can say 8/3 is equivalent to 40/15, because all we're doing is multiplying each number by 5 to get our equivalent ratio. So let's reflect. How can you write equivalent ratios? Well, just like we did up here, multiply both numbers in the ratio by the same number. So, the next question says, a cafeteria worker knows that it takes 3 bottles of juice to serve a table of 18 students. How many bottles of juice are needed for 24 students? How many bottles of juice are needed for 42 students? So, we can picture it by using a diagram to represent the ratio of 18 students to 3 bottles of juices. So you can see here's our 18 students over here with the smiley faces and our 3 bottles of juice. We can also make a table to model it. So here you can see we have our 18 bottles of juice, or 18 students with our 3 bottles of juice. So to figure out what our rate is, just like we were doing last week, we divide both numbers by 3. It gives us a bottom number of 1, and 18 divided by 3 gives us 6. So that's where we got our beginning rate. Now that we know our beginning rate, we can then go to figure out and fill in the rest of our table. So, how do I get from 1 to 4? I would multiply it by 4, so that means I would do the same thing to the top, times 4. So, 6 times 4 would give us our 24. Then I do the same thing for the next one. 1 times 5 gives us 5. So 6 times 5 gives us 30. And then 1 times 6 gives us 6. And 6 times 6 gives us 36. And then 1 times 7 gives us 7, and 6 times 7 gives us 42. So I'm basing it all on our rate so that we can see how to get from one to the next. So now that we've done that work over there, it'll kind of help guide us through these questions. So number 2 says, what is the ratio of the number of students to the number of bottles of juice. Our original ratio that they gave us was 18 to 3. That's our original number. They said 18 students to 3 bottles of juice. Number 3, what is the related rate for this ratio? Explain how the diagram represents this. Well, for our related rate, we had to take our original ratio, which was 18 to 3, and we divided by 3 to get 6 over 1. So if we look at how the diagram represented that, it showed us 6 students, or smiley faces, for every bottle of juice. And it did that by splitting the students into 3 groups of 6. Number 4, look at the table. What is the unit rate? And then tell how you know. Our unit rate, based off the table we filled out, and based off what we did up here, our unit rate is 6. And we know this because the number of students is 6 times the number of bottles. Okay, number 5, use the unit rate to complete the table. How many bottles are needed for 24 and 42 students? So we did that on the other side. So for 24 students, we needed 4 bottles because we multiplied the 6 by the 4 to get our 24. And then for 42 students, we needed 7 bottles because we multiplied 6 by 7 to get the 42. Right, number 6, how do you use a table to show equivalent ratios? Well, we write the ratio given. Then identify the rate and then we use multiplication to find equivalent ratios. Now, take a moment and work through number 7 and 8 on your own. Pause the video, and in a few moments, once you've tried these, then you can resume the video to check your answers. Okay, number 7 says, Michaela travels 15 blocks on her skateboard in 5 minutes. At this speed, how many blocks can she travel on her skateboard in 12 minutes? So, first thing we need to do is write our original ratio, which is 15 to 5. So then we find our unit rate, or our rate, so that we know how many blocks in 1 minute. So we would divide top and bottom by 5. Gives us the bottom number of 1. 15 divided by 5 would give us 3. So we know she can go 3 blocks in 1 minute. So if she can go 3 blocks in 1 minute, we would have to take our 3 blocks times the 12 minutes to figure out how many blocks she would go in 12 minutes. So 3 times 12 gives us 36 blocks. Number 8, a seamstress uses 12 yards of fabric to make 3 costumes for students in the choir. How many yards will she need to make costumes for all 25 students? So, start with your original ratio, which is 12 yards to 3 costumes. We're going to divide by our bottom number. 12 divided by 3 is 4 over 1. So, now that we know she can make or use 4 yards for each costume, we can take our 4 yards and multiply it by 25 students, because that would be 25 costumes, and that gives us 100 yards. The next problem says a 4-ounce serving of yogurt has 8 grams of protein. How many grams of protein are in a 10-ounce serving? How many grams of protein are in the whole 16-ounce container of yogurt? So we can use a table to show equivalent ratios. Here you can see we have the original ratio they gave us, which they divided both by 8 to get 1/2. And then you can see how they multiplied to get to the other ratios. You can also plot the ordered pairs on the coordinate plane. You get these by completing the table like we did up above. So, once you have your table, then you can then make ordered pairs. So the first one was 1 to 2. So you put, sorry about that, you put your 1 to 2 into a coordinate pair, and then 4 to 8, and so on. And then that's where those dots are. So now let's answer a few questions over these. Number 9 says, what is the ratio of ounces of yogurt to grams of protein? Well, our ounces of yogurt was 4, and our protein was 8. Number 10, look at the table. How many grams of protein are in 1 ounce of yogurt? So that's where we took and we found our 1 to 2. Number 11, each point on the graph shows an ordered pair from the table. Fill in the blanks to show these ordered pairs. So this is like I was showing you on that previous page. So we would have 1 to 2. Each set of numbers would become an ordered pair. You have 4 to 8. Your 10 was to 20, and your 16 was to 32. How are the numbers in each order pair related? Well, the protein is twice the number of ounces. Number 13. The ordered pair 10-20 means 10 ounces of yogurt to 20 ounces of protein. The ordered pair 16-32 means that we have 16 ounces of yogurt to 32 grams of protein. So number 14 says the table and graph show equivalent ratios. How are they similar? How are they different? Well, they are similar because both show equivalent ratios. As ordered pairs. The table shows them in column, so above each other, and the graph in points. So, in our table, the ordered pairs are shown one number above the other, but when we put them into the graph, we're putting them in as points on the coordinate plane. So, now, I need you to answer 15 and 16 based off what we did up above. Take a couple minutes, pause the video, try to work them out, and then once you are done, you can resume the video to check your answers. Okay, so number 15 says, on inline skates, Bradley skates 4 miles in 20 minutes. At this speed, how long would it take him to skate the entire length of a 12-mile bike path? So we need to set up our ratio. So we would do minutes to miles, which is 20 over 4. Then we find our rate. So we're going to divide top and bottom by 4. 20 divided by 4 gives us 5. 4 divided by 4 is 1. So we know he goes 1 mile every 5 minutes. So if we want to know a 12-mile bike path, we would do 12 times 5 to get 60 minutes. Number 16, the cost of 5 team sweatshirts is $90. At this price, how much would it cost to buy sweatshirts for a whole team of 15 players? So we need to know the price of one sweatshirt. So we do $90 over 5, and then we're going to divide both sides by 5. 90 divided by 5 gives us 18. 5 divided by 5 is 1. So we're going to take $18 per sweatshirt and multiply that by 15. When we multiply those together, we get $270. So it would be $270 for 15 sweatshirts. So now what I need you to do is to log into Classroom and go ahead and take the exit ticket. There are 3 questions on the exit ticket. You can show your work along the sides of your paper here, or you can get out a separate sheet of paper, either one. Once you submit the exit ticket, I want you to come back into your instruction workbook and work on page 22 and 23. Remember, this won't be a grade. It's just trying to work on some extra practice with using equivalent ratios. We will go over these tomorrow.